Welcome back to Module 2 on classical geometric partitioning of an angle or a particular angle in some fraction, still in the domain of classical geometric construction of full number angles in general. My name is Kimwe Alex from Yale University of Science and Technology. In this presentation, I'm going to teach how to construct and trisect an angle of 21 degrees. I will start with construction of 14 degrees, then I produce 7 and make 21. Right away, I'll go to the GeoGebra software and restart the construction. Before that, I would like to prepare the necessary tools for use in this presentation. I would like to work with some points. I raise the tool from that toolbox. I need some straight line. I need to do the angle bisections. I need to use the compass tool in the construction and possibly some geometric transformations. The rest of the tools are okay, and I choose to pick from these toolboxes. Now I start by drawing my my straight line between the 2 points A and B as usual, and this way I'll place maybe from here my point A and point B at that distance. I'm not considering the units between the two distances. The number of units, that is the distance between the 2 points. Now I have my baseline. As usual, I'm going to construct a third point that should be equidistant between these 2 points A and B. And to do that, I'm going to use to start with the radius AB and the center B. I'll again construct another circle starting from point B to point A, with point A as my center. And this point of intersection is the point I'm calling the point C. I have my point C that way. I'm required to join point B to point C using a straight line, and there we have it. Or better, I'm going to delete this and use the line segment that the figure does not appear here. That's that. Next, I'm going to bisect that chord BC using this tool. I do that, and that. I have my bisection in place. We have these points of intersection. This point between this bisector and this chord, and the other point of intersection is between the curve BC and the bisection line, or the line that bisects the chord BC. I'll use the labeling tool here to label this point as point D and this as point E. Next, I'm going to bisect angle EDB so that I generate a chord GF, where F is the point of intersection between the curve BE and the bisection or the bisector through point D. I'll go further and bisect angle EDF that way. Now, having the bisection in place, I need to accurately label that point of intersection between the bisector and the curve EF. I'll zoom in the figure slightly that I can accurately label this point as point G. With the chords DG and DF, we have the right weapons for use in these constructions, or the necessary tools for using this construction. I'll start by construction of that 2, and from that 2 I'll be able to get 14, and in a simple way as I'm going to show. So I use the compass tool from this toolbox as usual to start with the chord DF and the center E. Now I change the appearance of that curve or curvature into that, and the point where this arc cuts the curve EC, I label this point as point H. That's my point H. I'll again use the compass tool to carry the distance DG. I'm now going to use point H as my center, and I make an arc that cuts the curve EH at a point I. I would like to change the appearance of that into that. I'll slightly zoom in using the magnification tool so that I can label this point as point I. And I got my 32 degrees. That is the angle IAB, which is 32. Next, I'm going to do a bisection of the angle IAB so that I get 16 at a point J. But before I label the point G, I'm going to change the appearance of that line into that for some good appearance. And then I use the labeling tool to label this as point J. Now clearly angle EAB is 30 degrees. It's the angle bisector. The line EA is an angle bisector of the angle CAB. If we join the point C to point A using a straight line, we see that triangle ACB is an equilateral triangle, and one of the properties in an equilateral triangle, or the size of every internal angle in that equilateral triangle, should be 60 degrees and the sum up to 180. So if I do a bisection of any of the angle, I'm dividing the angle, one of the angle at the vertices, internal angle at the vertices, into two equal portions of 30 degrees each. Now angle EAB is 30 degrees. Angle JAB is 16. The difference between angle EAB and JAB is 14 degrees. So what I'm going to do next, I'll zoom in this figure slightly that way. I use this tool to navigate the figure inside slightly, that, or to move the figure slightly inside, so that I can do some more geometrical, constructions or operations. And in this case, I'll do geometric transformation. I want to map the point B about point A, or reflect the point B about point A to point B prime. I'll then use this compass tool to carry the distance EJ, that's 14 degrees. I place it at this point, or point B prime, as my use point B prime as my center. I'll change the appearance of this into this. It looks nice. I'll use the labeling tool here to label this point of intersection as point K. Now I will join point K to point A using that line segment, and I'll use a different colored line to join the two, and that's it. If we measure the size of this angle KAB is 14 degrees, we get it exactly. So next, I'm going to do a bisection of the angle KAB prime. KAB prime, and here I should be having 7 degrees. I label this point of intersection as point L. I change the appearance of this into the same color because the lines hold some property I want to demonstrate. I'm again going to use the compass tool to carry the chord KL, and with point K as my center, I make an arc that cuts curve KC at a point M. I label this as my point M. I change the appearance of this again into another color, possibly that. Now let it be a color that does not bring some confusion. Or resemble those colors. So the colors, I can pick that. Fine. And it's not least, I'm going to join. I can use the line segment to join M to point A. Change again that color into that, and I have it. That means angle LAB should be 7 degrees, and angle MAB should be 21 degrees. We have it. And it's now very simple to divide an angle into the given portion, or into the required portion. So for me to prove this construction is correct, I am now going to use the compass tool to carry the distance B prime M, and with point B as my center, that I make an arc that cuts the curve BF at a point I'm going to label as point N. Before I do the labeling, I slightly zoom in the figure for accurate labeling. This, and I have my point N. I zoom out slightly so that I can operate on the figure. Why there's no sense of carrying that. I have my figure that way. I'm going to draw a straight line. I'm going to draw a straight line between point N, I can pick it from here, or through points N and L, and I'll make that line, take that color, I'll leave it at that for some distinction. I'll then minimize the figure again and move it inside that way. Now I label this point of intersection between the baseline at this point. I want to be sure it's correctly labeled. Yes, that point as point O. What that means is angle LOA should be 7 degrees. I'm interested in the scale of 0 to 180 degrees. And again, that may be 7 degrees. And using the Alex property or proof, as we saw in the introductory presentation or during the introduction of this module, a construction can only be correct if these properties do hold. And we have proven 21 to be a correct construction, a very exact one. And I'm going to use the canvas tool and the radius AB with my point L as the center of construction. I draw a circle and I make it green, and that circle passes through point A. So this circle brings the concept of the compass equivalence theorem, which Alex employed in the geometrical verification that his theorem was correct. That starts with the trisection of 21, construction 7, construction 14, and so many other properties you can construct using Alex's method. In the next video, I'll be showing how to construct how to trisect an angle of 72. That shows we need to be able to construct what size? 24. I'll show how to create 24 in a very simple way. Thank you for viewing. Please remember to subscribe.